These are some visuals of um, hyperboloids and toroids, and I just wanted to make this video because I haven't. I guess I should say that people that follow me haven't really understand certain concepts like distinctions of hyperboloidal geometry, which this is a one sheet hyperboloid. It's like the inside out of a circle, but it goes like this. It's spun at, like, how do I say that? Imagine this, but it's like spun around here. Really bad physical analogy right there, but this is the inner part of a horn torus, and this specifically because this is going through itself, is the inner part of a spindle torus, which a spindle torus makes a spindle stereometric geometry within itself. And this is a two-sheet hyperboloid, which this one doesn't go through the center, but this one does. Yeah, this is not this, or the orientation is different, and this is this, except that it goes through itself to the point that it becomes a sphere. And likewise, this could be squished together into a sphere, just as this. And this is also a hyperboloid, but it's not. There's a distance between the center, and this is a quasi-hyperboloid because it's more of a transversely compressed sphere, longitudinally elongated, which the inverse of this will be this, which is a quasi-torus. This is a quasi-hyperboloid, quasi-torus, which the quasi-torus is longitudinally compressed and transversely, what did I say? Transversely expanded, yes. And this is not the same as this, even though two-dimensionally it looks very similar to each other. This is more of a cross-section of a torus and a quasi-hyperboloid, which this torus is more like this and not this, which this is a quasi-torus that doesn't have a center hole. It's more like the geometry of the red blood cell, but the red blood cell geometry, or stereometry specifically, because it's three-dimensional, doesn't have a circle or an empty hole, so to speak, between it or within it. And this is a more simplified juxtaposition of hyperboloid and a torus, but there's no it's like this and this, but it's more like, how do I say it? It's not like this because there's a space between the hyperboloid and the toroid, but this is like a point, torus and a point hyperboloid. It meets at the point, but only at the point, not between it or around it, for like this one as an example. And this is an attempt of mine of trying to show you that the types of geometry that's going on simultaneously, which this here could be a one sheet torus, this and this could be a together as a two sheet torus. I mean, this is torus. I mean, this it will be a one sheet torus, hyperboloid, and this will be a two sheet hyperboloid together. And this there's also there's also a sort of quasi I'm not sure to say quasi, but it's more like a egg-like geometry that's happening. It's like, imagine this but without the center part. It's like gapped, so it sits within a pressure gradient of sorts between the center plane, or away from the center plane, but it's not completely a true hyperboloid. So it's kind of a quasi hyperboloid, but like this, the middle part is gone, and it's drawn there due to the field that it is being drawn towards the center. And moving on, and this is how I will visualize a simple representation of the magnetic and the dielectric and the electrical wave that is happening between the magnetic and the dielectric. And this will be the hypertoroidal two-dimensional void of the ether. It's not, the ether's not void, but it's like the voidance of magnetic and the dielectric against itself, which these cancels out each other. And I try to make the dielectric field like this, but I didn't put more lines so that you could visualize better. But anyways, moving on. This is what people mistaken this for, which this would be generally mistaken for a quadrupolar field, which is really more of a secondary or second order field dynamic movement of the first order field that is bipolar, which this will be quadrupolar, but it's really this part is the same as this part here. And so this part will be the magnetic and this part will be the dielectric, which fights against each other when there's another matter or magnetic field moving magnetic field against another moving magnetic field. So anyways, moving on again. There's this diagram that I made that explains that it's not the same as this, but this still has a sort of attraction mode going on around the repulsion mode. So these two power lines that are going at the same direction would have repulsion at the center, yet also having an attraction at the center simultaneously. Yet that attraction is more around the two of the power lines rather than one of them. For the field of one of them would interact with the field of the another power line that's parallel to each other going to the same direction. Yet together they share one outer field that does bind together closer, which is not the same as this because this is more of a cross section of a toroid, which just goes like that. So this sine wave or whatever is more like it's on the surface of the torus, but it's not really, how do I say, important as the interactions that's going on between these modalities, which differs between voltage over time and all that. So if there was a loop of wire, it'll be right. It will look like it's going through the center, but it's more like a half circle going up out of the page and back into the page from the center of the magnetic fields, which really there's not much difference between longitudinal and magnitudinal or whatever, or transverse or longitudinal fields, which Ken really tries to make a longitudinal field to be different from a transverse field, but they're both in motion, and together they make a helical geometry upon the torus, which I wanted to say that the so-called scalar is not really a scalar if he calls it a longitudinal, because it's not scalar if it's a part of a vector, which a longitudinal vector exists, and he tries to like denounce the attribute of the longitudinal dielectric as anything like separate from the magnetic, yet at the same time he tries to prioritize the dielectric before the magnetic, but together they're the electrical field. And so if this was some incoherent matter and another incoherent matter, this part would be the intermediary pressure mediated point non-source specific erasure of force and motion into inertia and acceleration. But anyways, going back to this page, and this page. This is again different from what two people are saying, which I'm only gonna name one of them, which is Ken, which Ken says that it's coming in together because it's the same as this geometry, but it's really not the same geometry, and the reason why it's coming together is on the outside and not the inside, because the inside is there's repulsion, but the outside there's attraction. And there's the other people, there's more than one actually, but the other people that says that it's only repulsion, just don't believe in the outer attraction that goes on against the inner repulsion that is due to the inner field that comes out interacting with the other wires inner field that comes out, which has a net field that goes to the same direction as the two parallel wires that is will be the ether. So in a sense, Ken Reader is right but also wrong, and other people are right but also wrong. So yeah, this is why the two parallel lines come together when there's more energy put into the system, because this contracts into itself while repulsing away from itself at the same time. And I guess that's about it for this video. I'll get into more stuff, but hopefully not on paper for now. And I'll see you in the next video. Bye bye.